Hello, I'm Tom Nahumi from Dell EMC. In this demonstration video, I'll be showing the Dell EMC PowerMAX CSI Driver 1.5 features and installation method for OpenShift using the Dell operator. The first step is installing the driver. In the latest version, CSI 1.5, we've added support for RedHat OpenShift 4.5 and 4.6 with RHEL and CoreOS worker nodes. The CSI driver can be installed using Helm and the Dell CSI operator. In order to automate and simplify the CSI driver installations on OpenShift, we've developed the Dell CSI operator. This is a Kubernetes native application which helps in installing and managing CSI drivers provided by Dell EMC for its various storage platforms. Dell CSI operator uses Kubernetes custom resource definitions to define a manifest that describes the deployment specification for each driver to be deployed. Multiple CSI drivers provided by Dell EMC and multiple instances for each driver can be deployed by the operator by defining manifest for each deployment. As you can see, my OpenShift cluster is running version 4.6, which is based on Kubernetes 1.19. There are no storage classes or persistent volume claims yet. In order to install the operator, all you need to do is navigate to the operator's hub, search for the Dell operator, and click Install. The process takes a few seconds to complete. Once done, we can install each and every one of the Dell CSI drivers directly from the OpenShift user interface. The operator is fully certified and supported by RedHat. Before installing the CSI driver, we need to create a secret with the PowerMAX credentials in the same namespace as the driver. For the purpose of this demo, I'll be using PowerMAX version 9.2. From the Installed Operators tab, I'm clicking on the Dell CSI operator and then navigating to the CSI PowerMAX tab and selecting Create CSI PowerMAX. Here, I'm specifying the driver name and clicking on the YAML view to provide the array details. First of all, I'm specifying the namespace that the driver will be installed in. Version 1.5 adds support for CHAP for iSCSI protocol. The driver uses a provided secret to configure the iSCSI node database on each node with iSCSI access. Once CHAP is enabled at the PowerMAX array level, by creating new hosts on the PowerMAX array, the driver will populate host CHAP credentials with the provided values. PowerMAX endpoint defines the IP address of the Unisphere for PowerMAX. Kubernetes cluster prefix defines a prefix that will append onto all resources created in the array. This is a unique per Kubernetes or CSI deployment. PowerMAX port groups defines the port groups at the array level for iSCSI only. PowerMAX arrays define the array ID, which will be managed by the driver. The protocol defines what transport protocol to use, iSCSI, FC, or Auto for automatic detection. Next, we have the snapshot class. This object will be used to create snapshots volumes on the array. A storage class provides a way for administrators to describe the classes of storage they offer. In this example, I'm defining a storage class called Bronze. This storage class supports online volume expansion and will be the default storage class. In addition, we need to define the storage resource pool, the array ID, and the service level, which represents the Bronze storage pool in PowerMAX. Also, we have two additional storage classes defined by default. Starting from version 1.5, the CSI PowerMAX driver supports topology-aware volume provisioning which helps Kubernetes scheduler place PVCs on worker nodes which have access to the backend storage. It provides an efficient way to provision applications only on nodes which have access to the PowerMAX array, in case we have nodes that are not connected to the array, such as infra nodes. The difference between the two is the volume expansion parameter. At this stage, we are ready to install the driver. I'm clicking Next to continue. Within a few minutes, the driver is up and running. By navigating to the Deployments tab, we can see the PowerMAX controller, which consists of two pods. Starting from version 1.5, the CSI PowerMAX driver supports running multiple replicas of controller pod. At any time, only one controller pod is active, as known as leader, and the rest are on standby. In case of a failure, one of the standby pods becomes active and takes the position of leader. This is achieved by using native leader election mechanisms utilizing Kubernetes leases. Additionally, by leveraging pod anti-affinity, no two controller pods are ever scheduled on the same node. In addition to the controllers, we have two nodes pod running on each of the worker nodes. By navigating to the Storage tab, we can see that the three storage classes have been created. In addition, we have the Snapshots class, which is used to manage array-based snapshots. As part of the driver installation, it automatically detects the iSCSI initiators and registers the OpenShift workers as hosts on the PowerMAX array. With that, let's start to discover the CSI features. I'm navigating to the Stateful Set tab and creating new 3-replica Nginx stateful set. I'm providing the name and the namespace and specifying the storage class and the requested PVC size. Within a few seconds, the Nginx pods are up and running, connected to their persistent volume, which have been created on the PowerMAX array and mapped to the OpenShift workers by the CSI driver. Starting with version 1.4, the CSI PowerMAX driver supports expansion of persistent volumes. This expansion is done online, that is, when the PVC is attached to any node. In order to expand the volume, we need to edit the PVC using the OC command, and then change the volume size and save the file. As you can see, the volume size has changed in the background, as well as the PVC and PV objects, while the volume is still mounted on the running pod. Next, I'm going to create a snapshot of the PVC. I'm navigating to the PVC in OpenShift UI and clicking on Create Snapshot. Then, I'm selecting the storage class and clicking Create. Once the volume snapshot has been successfully created by the CSI PowerMAX driver, a volume snapshot content object is automatically created. Once the status of the volume snapshot object has the Ready to Use field set to True, it is available for use. By navigating to the storage group in Unisphere and clicking on the Data Protection tab, we can see that a new native snapshot has been created in PowerMAX. Next, I'm clicking on the snapshots I've just created and selecting Restore as New PVC. I'm providing the name, storage class, and size, and then clicking Create. Within a few seconds, a new writable volume has been created from that snapshot. We can confirm this from Unisphere as well. One of the new CSI features is the ability to clone a PVC from another PVC as a source. I'm clicking on Clone PVC and then selecting the name and the size. Within a few seconds, a new writable volume has been created from that volume. We can also confirm this from Unisphere as well. Starting from version 1.4, CSI PowerMAX Driver supports raw block volumes. Raw block volumes are presented as a block device to the pod by using a bind mount to a block device in the node's file system. There are some specialized applications that require direct access to a block device because, for example, the file system layer introduces unneeded overhead. The most common use case is databases, which prefer to organize their data directly on the underlying storage device. In this example, I'm creating a new PVC called block PVC. The volume type is set to block. In addition, I'm creating a new pod. The raw block device will be mapped as dev xVDA once the pod is up. I'm creating the pod and waiting for the pod to start. By navigating to the OpenShift UI and selecting the new pod I've just created, we can open terminal to the pod and verify that the new device is mapped to the pod as a raw device. I really hope you find this demo useful, and thank you very much for watching.